China just dropped a bombshell that could shake the entire tech world. Starting December 1st, any lithography-related gear that contains 0.1% or more China-origin rare earths, no matter where it's built or shipped, will need a Chinese export license. At the same time, Beijing has put advanced chip equipment into a case-by-case approval system. If that sounds like a small rule, it isn't. Think of it like a power plant refusing to sell coal. The machines that make the world's most advanced chips suddenly face a choke point. The Netherlands makes the most important of those machines, ASML's lithography systems. But many of their parts depend on rare earths refined in China. Pull that ingredient and the whole recipe goes wrong. Today we'll unpack why Beijing targeted the Netherlands, how a seemingly bureaucratic rule can stall factories and car production, and what that means for jobs, supply chains, and global politics. Let's start at the beginning, because to understand this shock, you first need to know why rare earths are the hidden heartbeat of modern chips. When people hear the term rare earths, they often think they're literally rare, but that's not quite true. These are 17 metallic elements found in everyday electronics, from smartphones to electric cars. What makes them special isn't scarcity, it's how incredibly hard they are to refine. And that's where China dominates the game. After paralyzing Europe's car industry, China launched a second, more strategic counterattack, one that went straight for the Netherlands' technological heart ASML, the world's only producer of extreme ultraviolet lithography machines. On December 1, 2025, China's new rare earth export control law officially took effect. It contained two clauses that honestly sent shockwaves through the global semiconductor industry. First, the so-called 0.1% rule. From now on, any lithography-related equipment that contains just 0.1% or more China-origin rare earth materials, no matter where it's built or shipped, must apply for a Chinese export license. And not only that, the final end user must be reported directly to Beijing. That means no middlemen, no loopholes, and no secret re-exports through third countries. Second, any product or material connected to advanced semiconductor production, such as equipment for 14-nanometer chips, 256-layer memory devices, or high-end testing tools, now requires case-by-case approval from China's Ministry of Commerce. In other words, every shipment gets individually reviewed, and nothing moves without a green light. This was a surgical strike. It didn't block the entire semiconductor trade. It specifically targeted the Netherlands' most powerful export lithography machines. These machines can't operate without rare earth materials refined in China. Even a 0.1% restriction is enough to slow, stall, or even stop production. For the Netherlands, this was a devastating reality check. Their cutting-edge chip technology still depends on the very materials controlled by the country they've been trying to restrict. And as we'll see next, this single policy exposed just how fragile ASML's supply chain really is, and how dependent even the most advanced Western tech remains on China's rare earth power. ASML is often called the crown jewel of Europe's technology industry. Its machines are the size of a bus, cost over $150 million each, and are used by chip giants like TSMC, Intel, and Samsung to print the world's most advanced microchips. But beneath all that engineering brilliance lies a simple, uncomfortable truth. ASML can't build its machines without China. Here's why. Inside every lithography system are hundreds of ultra-precise parts that depend on rare earth materials. For example, the EUV lenses are polished using high-purity cerium-based compounds, materials refined almost entirely in China. Each machine also contains over 10 kilograms of rare earth permanent magnets, crucial for the internal motors that position wafers with nanometer accuracy. And the magnetic levitation system that keeps the wafer stage floating? That relies on heavy rare earths like dysprosium and terbium, both almost exclusively sourced from China. ASML has tried for years to reduce this dependence. They've tested substitutes, invested in recycling, and even sourced small batches from Southeast Asia. But every attempt failed. When they replaced Chinese magnets with lower-grade materials, costs shot up by 40% and performance dropped by around 30%, completely unacceptable for precision manufacturing. The numbers tell the story. China supplies about 90% of the world's refined rare earths, and ASML alone accounts for over a quarter of China's total rare earth exports each year. Without those materials, production simply can't continue. Right now, ASML's inventory of rare earths can sustain operations for roughly 8 weeks. After that, every delay in export licenses could cut monthly production by 15 to 20 machines, leading to potential revenue losses exceeding €3 billion a year. And the damage wouldn't stop there. Every missing ASML machine means one less chip factory upgrade, one less tool for companies like TSMC or Intel to produce next-generation processors. The ripple effect would hit everything from smartphones to AI servers. So, when China tightened its rare earth exports, it wasn't just about revenge, it was about control. A quiet but devastating reminder that the world's most advanced machines are still built on China's raw materials. But this standoff doesn't just threaten one company. It threatens the entire global semiconductor supply chain. China's countermeasures didn't just affect Nexperia or ASML. The impact rippled across Europe and beyond. Automotive factories, tech firms, and even supply chains in North and South America started feeling the shock. In Germany, Volkswagen's Wolfsburg plant lost over €100 million per day, while BMW's Munich plant saw delivery times for high-end models double. In North America, Honda had to cut capacity by half at its Ontario assembly plant. Across Europe, over 12,000 workers faced temporary layoffs. The economic losses in just 2 weeks topped €3.5 billion. And automakers warned that if chip shortages continued, parts of the industry could face irreversible damage. The problem is simple. Nexperia's automotive power chips are everywhere. They control brakes, lighting, high-voltage power modules, and countless safety-critical functions. Almost every major car maker, from Volkswagen and Toyota to Tesla, depends on them. Switching suppliers isn't easy. Automotive-grade chips require months of testing and certification before they can be used safely. Even more, the standoff exposed a geopolitical paradox. The Netherlands tried to control a Chinese company, yet its most advanced technology remains deeply dependent on China. Europe's automotive and tech sectors suddenly realized that, in this high-stakes game, cutting China out comes at a huge cost. As warnings came from Germany, France, and Italy, EU regulators hinted at invoking emergency measures under the EU Chips Act, which could place wafer fabs into projects of common European interest, bypassing Dutch control entirely. The message was clear. If the Netherlands continued to suppress Nexperia, the entire European chip supply could be pushed to the edge of collapse. And just when Europe was reeling from this realization, China prepared its final decisive move, one that could reshape the semiconductor world for years. Here's the big picture. The Netherlands tried to assert control over a Chinese company, but the real power, production, materials, and know-how stayed in China. China's countermeasures, from cutting Nexperia exports to controlling rare earth supplies, revealed a fundamental imbalance. Europe may hold the technology, but China controls the lifeblood that keeps it running. The stakes are enormous. Car factories shut down, global supply chains tremble, and billions of euros in output vanish in days. ASML, Europe's tech crown jewel, can't operate without rare earths. And the ripple effects aren't just economic. They're geopolitical, shaping how countries think about supply chains, alliances, and technology dependence. What's next? Europe must decide whether to negotiate, find alternative suppliers, or face prolonged disruptions. And the world is watching closely. Every delay in chips, every shortage in cars or electronics, highlights how fragile the high-tech ecosystem really is. So here's a question for you. Will Europe adapt and survive this new reality, or will dependence on China continue to dictate the rules? Comment below with your thoughts, and stay tuned, because in our next video, we'll explore how companies like ASML and Europe's auto giants might respond, and what that could mean for jobs, technology, and global power.